Welcome to Maths for All. I'm Aisling Flynn. This is exam practice. So in this video we have a 25-mark question at ordinary level, Leaving Cert on functions. Okay, so part A begins with a quadratic equation, okay, which is what you've learned in algebra, and it asks you to solve the equation. Okay, so we've learned that there's two ways to solve a quadratic equation. Okay, one we can go the factorizing route, and because it doesn't specify, you're free to use what we call the minus b formula or the quadratic formula. Okay, I'm going to factorize. Remember, to solve a quadratic equation means to find the 2 points on a function where it crosses the x-axis. So when is the function equal to 0? And we expect 2 answers. Okay, so factorizing, different students learn to do this in different ways. One way is to use the grid method. Okay, so here I'm putting my quadratic bit, the x squared there, and the constant bit in the bottom right. Okay, and what we're trying to do is we're trying to find the 2 factors or the 2 multipliers that gave me these 3 pieces here in what's called this quadratic trinomial. Okay, so what do you multiply by to get x squared? So we're focusing on the first term here. Well, we would multiply x by x gives x squared. And what do you multiply by each other to make 6? In particular, minus 6. Okay, so there you have options. It could be 1 times 6 or it could be 3 times 2. Okay, but which option will result in this middle term when you combine them? What will give you a minus 1? Okay, and that will be the 3 and the 2 terms. Okay, to make minus 1 we would have minus 3 plus 2 gives minus 1. Okay, so the factors of the 6 that we're going to use are minus 3 and plus 2. Okay, and let's just fill in the diagonal here to make sure we're right. So x by minus 3 gives minus 3x, plus 2x by x gives plus 2x, and on the diagonal there, yes, that makes minus x. All right, like I said, you may have learned to write that a different way. Whichever way you get there, make sure you arrived at the correct factors. Okay, so one factor is seen here along the top of the table is x minus 3, and the other factor is x plus 2. So when you multiply those two, you would get back our x squared minus x minus 6. Okay, so we're saying that instead, so the 2 factors equals to 0. Okay, so logic tells me if a times b equals 0, well then either a equals to 0 or b equals to 0. So that's the next step in solving. We put each factor equal to 0. So this factor here, x minus 3 equals 0, or x plus 2 equals 0. Okay, they're the 2 scenarios, and solve for x with each of these little equations. So for this one here, we're going to add 3 to both sides, and we'll get x equals 3. Or for the second one here, we're going to take 2 from both sides, and we get x equals minus 2. All right. Okay, so that is solved. So let's check the marking scheme. Did we get it right? Yes, we did. There were 15 marks this year going for that, and you see that it was acceptable for either or, factorizing here on the left, or to use your quadratic formula here on the right. Same answers. Okay, there's opportunity to gain partial credit. If you did some correct effort of factorizing, you might get, this is 15C, you might get 5 out of 10. Okay, or out of 15 rather. if you wrote down the quadratic formula, you'd get 5 out of 10, or if you just tried some numbers and see would they work, you might get 5 out of 15. Okay, high partial credit, if you got as far as factorizing, you get 10 out of 15, or if you got it mostly right. Okay, if you correctly substituted into the quadratic formula, you get 10 out of 15 even though you didn't finish correctly. Okay, or if you found the correct answers by trial and error, okay, you'll get 10 out of 15. So part B, the graphs of 4 quadratic functions are shown below. We'll have a look at those in a minute, but the question is down here at the bottom. Which of the graphs above is that of the function f of x is x squared minus x minus 6? Okay, so hopefully you'll recognize this from part A. When we solved when was that quadratic equal to 0, and we found out that we got roots of, it was minus 2 and plus 3, so perhaps we can use that information here. So we're going to look for graphs that have roots of minus 2 and plus 3. Okay, so let's look at the first graph, graph A. Now roots are where the function crosses the x-axis. When is the function 0? So here we have roots of minus 3 and plus 2. So the signs are incorrect there. So that means we can cross out graph A. It's not graph A. And for the same reason, we can look at graph B. It's minus 3 and plus 2. So that's not right. Okay, so we'll discount that one. So let's just check the roots on C and D. We have minus 2, which is correct, and plus 3, and minus 2 and plus 3. So the roots are okay in these ones. So what's different about C and D? Well, one is hill shape and one is U shape. And you'll have learned that when you have a quadratic function with a plus or positive x squared term, that you have a U-shaped graph. If you have a negative x squared term, you get a hill-shaped graph. So for that reason, we have positive x squared. For that reason, we're looking for a U-shaped graph, which is graph D, and not a hill-shaped graph, which is graph C. So my answer, and write it explicitly, is graph D. Okay, make it very clear which one you're choosing. Okay, so process of elimination. Now there were 5 marks going for that. Graph D, you either got it right or you got it wrong. So 5 or 0. Part C, the graph of g of x equals x squared minus 2x is shown on the diagram below. On the same diagram, you have to sketch the graph of each of the functions, h of x and k of x. We'll look at them more closely in a minute, okay? But first I will bring your attention to this word sketch. It means you don't have to go away and generate tables of points for each of the functions. We'll find some key points and join them up in the general form we expect, okay? And we're asked to label each sketch clearly. Okay, so let's start with h of x. h of x equals g of x plus 2. Now remember what g of x is. It's the function, and it is those values that come back when you put different values of x into the function. Okay, they are outputs. Okay, and outputs go on the vertical axis up and down, and the outputs of h will go there as well, and k when we get there. Okay, so this line here tells me that the outputs for h of x are the same as the outputs for g of x, but 2 bigger. Okay, 2 more. Or we'll see on the graph it's going to be up 2. So when x is 0, when the input is 0, you can see that g of x gives output 0 as well. but we've read that h of x will give us an output of 2 bigger, so I'm going to count up 2 blocks, 2 units, and mark a point for h of x. And we can do that for a number of points. So let's use the vertex here, so the bottom of g of x, and we'll climb up 2 boxes, 1, 2. We'll do the same for when x is 2. We'll climb up 2 boxes, and when x is 3, here's g of x, but let's climb up 2 boxes, and we'll do the same on the left hand side. And you can see that we get a number of points, okay? And we get a nice U shape, so it's identical in shape, just shifted 2 units higher. Okay, and to get full marks, I'm going to label it as asked, okay, h of x. Alright, so that's h of x, probably the more straightforward. Now the next one is for k of x. So maybe we write this to the side. So in this example, it is the input values that are compared and changes a little bit, okay? So what this is saying, it's saying that the when k has input x, okay, it has the same output as when g has input x plus 2. Okay, and I think for these kind of ones I really need to use actual numbers to visualize what's happening. So let's start with 0. So at x is 0 for the function k, it will have the same output as when g has input 2. So what am I doing there? I'm replacing x with 0. Okay, so let's look at g of 2. So here's x of 2, or x value 2. When g is 2, or when x is 2, g has value 0. And we translate that back to when x is 0, for the k of x, we should have 0 also. So I'm going to just highlight that in larger. Let's try it again though to figure that out. So let's try when x is 1. K should have the same value as when x is 1 plus 2, when x is 3 for g. Okay, so let's look at x is 3 here. G has a value of plus 3. It's plus 3 in height. So when x is 1 for k, we should have a point here. So what's happening? We'll do one more example. We'll do k is 2. Okay, will be the same as g of 4. Okay, when g has value 4, x input 4, it is 8 high. Okay, and that should be the same as when x is 2, 8 high for k. Now look at what's happening. What it's doing, it's shifting each point left by 2 units. So left 2, and the bottom one here, we went across here, we went left by 2. Okay, so that's what happens. Alright, we're shifting everything left by 2. Let's do the remainder points. Let's take the vertex down here at the bottom, shifted left 2 units. Goes to here. Now it's 2 units off your axis, not 2 boxes off the graph paper. Okay, this point here will go left 2 to here. This one goes left 2 to here. And let's take this one here, goes left, that goes off the page. This one here, yeah, we have enough now. Okay, so let's sketch that. Now it's the identical shape as the first one, but left by 2. Okay, and let's label it G or K of x. Alright, so let's recap there. So g of x plus 2, it goes up 2, but if you have changed the inputs by that, it goes left 2. Okay, and we did that when we studied quadratic function, so maybe look back over that. Now the marking for that, there was 10 marks going for it. There's 3 out of 10 if you got one graph right, the correct shape, okay, not necessarily correct position, or if you made some effort at evaluating H, okay. High partial credit, which is 7 out of 10 if they're both drawn correctly but not labeled, so make sure that you label them correctly, or if you went the wrong way, if you went up instead of down or right instead of left, okay. So that was a functions question.